Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0A94 indicates a performance issue with the DC-DC converter in the Honda Accord 2023 and newer models. The DC-DC converter is a crucial component in the vehicle's power distribution system, converting high-voltage DC power from the hybrid battery to lower voltage for use in various electrical components. This conversion is essential for the operation of devices such as the electrical accessories and control systems. When the powertrain control module, PCM, detects an abnormality in the DC-DC converter's function, it triggers the DTC P0A94 and stores this information for further diagnosis. This alert can help technicians pinpoint the cause of the performance issue to ensure the proper functioning of the vehicle's electrical systems. The DTC P0A94 describes a performance problem with the DC-DC converter, a crucial component responsible for converting high-voltage electricity from the hybrid battery to the lower voltage needed for other electrical components. The PCM, or Powertrain Control Module, plays a vital role by continuously monitoring the DC-DC converter's performance. If it detects a failure or malfunction, it will log the DTC. In the Honda Accord, the DC-DC converter is typically situated within the power electronics module, which is often mounted near the vehicle's battery. Understanding the relationship between these components is essential for accurate diagnostics. A failure in the DC-DC converter could compromise the vehicle's electrical system, potentially leading to other issues if not addressed promptly. Several potential causes might lead to the activation of DTC P0A94. The first consideration is a malfunction in the PCM, or Powertrain Control Module, which could misinterpret the DC-DC converter's operational data. Additionally, a failure in the DC-DC converter itself can directly trigger this error, indicating it may be unable to perform its conversion duties reliably. External circuit issues can also contribute, such as damaged wiring, poor connections, or short circuits that might disrupt the communication or power supply to the DC-DC converter. Properly identifying these causes is crucial for effective troubleshooting and resolution. The symptoms associated with DTC P0A94 can manifest in several ways. Drivers may notice warning lights illuminated on the dashboard, indicating an electrical system issue or hybrid power failure. Furthermore, if the DC-DC converter is not functioning correctly, there may be malfunctions in various electrical components due to inadequate power supply. This can include loss of function in accessories or inoperable control modules. Finally, drivers might experience reduced power availability, which could affect overall vehicle performance and reliability. Paying attention to these symptoms can assist in early diagnosis and prevent further complications. The initial troubleshooting step for addressing DTC P0A94 involves conducting a test drive of the vehicle and using the auto idle stop feature. During this process, it is important to observe how the vehicle behaves under various driving conditions. This can help identify if the vehicle intermittently exhibits symptoms related to the DC-DC converter failure. After completing the drive, turn off the engine using the auto idle stop feature. Gathering data during this step allows technicians to gather preliminary information on the DTC and any corresponding symptoms, facilitating further diagnosis. In the second troubleshooting step, confirming the Honda Diagnostic System HDS readings for the DC-DC converter is critical. Technicians should first check the HDS for values labeled as DC-DC converter CST error. If the value indicates a malfunction, it points directly towards concerns with the DC-DC converter performance. Conversely, If the value displays as normal, it suggests that the converter might be functioning properly and directs attention towards other potential issues within the electrical system. Thus, confirming HDS readings is paramount in directing the subsequent steps of the troubleshooting process. The third step involves inspecting the power supply and ground circuits associated with the DC-DC converter. This requires checking for short circuits in the DC-STS wire, ensuring that the resistance is greater than 1 megaohm in the off position. Additionally, a thorough inspection of the +B DC-DC1, +B DC-DC2 power supply circuits and ground connections is crucial. These checks help identify if any components in the external circuit are shorted or have open connections, as these issues could lead to improper operation of the DC-DC converter, triggering DTC P0A94. Maintaining the integrity of these circuits is key in ensuring reliable vehicle performance. In the fourth troubleshooting step, focus shifts to inspecting the output circuit of the DC-DC converter. Technicians must verify if any aftermarket electrical components are connected to DC-DC outputs, DC-DC out 1 and DC-DC out 2. Aftermarket installations can interfere with the natural functioning of factory components and may contribute to performance issues. By confirming that the output circuits are functioning as expected, technicians can rule out circuit problems as causes of the error. It's important to understand that verifying these outputs is part of establishing or eliminating potential failure points in the system. Next in the troubleshooting process, the internal circuit of the DC-DC converter must be inspected using the HDS. The technician should have the vehicle in the on mode and observe parameters including the DC-DC converter CST error and input-output errors. Normal readings across all these metrics suggest the external circuit is functioning well. If any of these parameters display abnormalities, then the inspection should extend to related components to identify sources of the dysfunction. This thorough assessment is critical in isolating the issue to either the DC-DC converter itself or other components within the electrical system. In this step, installing a known good DC-DC converter is essential for comparison purposes. By connecting this component, technicians can observe if the system operates normally and if the previous symptoms or DTC P0A94 reappear. This diagnostic method is particularly effective since it isolates the converter as a source of potential trouble. If the replacement converter eliminates the error, it's determined that the original DC-DC converter is defective and requires replacement. Conversely, if the issue persists, further investigation into other related components will be necessary to identify alternative failure points. The final step in the troubleshooting procedure is to conduct a thorough inspection of the powertrain control module, or PCM. If all other components and circuits associated with DTC P0A94 have been checked and found to be functioning normally, it indicates that the PCM may be the source of the issue. The PCM governs various vehicle functions and processes information from multiple sensors and components. Therefore, if it malfunctions, the entire system can be affected. Identifying it as the point of failure helps direct replacement efforts accurately, ensuring that the root cause of the performance issue is addressed effectively. After completing repairs based on the troubleshooting findings, it's crucial to conduct a final verification process. Start by using the Honda Diagnostics system to clear any stored DTCs in the PCM. Once cleared, conduct another road test to confirm that the previously identified issues have been resolved. This step helps ensure that all systems are functioning optimally and that DTC P0A94 does not reappear. Close attention to performance during the test drive will indicate if the repairs were successful or if further diagnostics are needed. final checks are essential for ensuring reliability and performance of the vehicle after repairs. To prevent issues like DTC P0A94 from recurring, regular preventive maintenance is essential. This includes routine inspections of the electrical circuits associated with the DC-DC converter and ensuring that all connections are sound and free of corrosion or wear. Monitoring the functionality of relevant components can also help identify developing issues before they escalate into significant problems. Vehicle owners should be advised on the importance of keeping their vehicle system well maintained and prompt reporting of any irregular behavior. A proactive approach to maintenance not only enhances vehicle reliability, but also prolongs the lifespan of critical components. In conclusion, DTC P0A94 represents a significant performance problem with the DC-DC converter in the Honda Accord. Understanding the roles of the PCM and the DC-DC converter is vital for effective diagnostics and repair. A structured troubleshooting approach, including information gathered from the HDS readings and circuit inspections, is necessary to isolate the issue efficiently. Once repairs are made, proper verification helps ensure that the vehicle operates as intended. Finally, emphasizing the importance of regular maintenance can mitigate future issues related to the DC-DC converter, ultimately contributing to a reliable and efficient hybrid system. Please like and subscribe to the channel. See you next time.